Thank you for tuning into this video focusing on long data format with Python Pandas. Now, typically in data analytics and data science in general, there's really the typical structure of data is in two dimensions, row by column. And within this two-dimensional structure, two different formats really is the predominant form. And that's wide with many related columns or long with many long rows. And ideally, long formats is the preferred structure for the analytical operations. This includes merging, aggregation, modeling, plotting, reporting, and still other functionality. And the purpose of this video is really to illustrate that point more clearly. And we'll be using data from the US EPA Greenhouse Gasses. They have a nice data portal where users can click for various both graph as well as data table, and from that data table you can output CSV files. So after importing our packages for this notebook, namely pandas and the graphical interfaces MATLAB and Seaborn, we're going to dive into this data, and we can immediately see really the wide format. In one of the outputs that from that data explorer. And as you can see here, it's pretty a wide data set, 30 columns for each specified year of emissions for delineated by IPCC sector. But no, one good thing about a wide format is that it really is digestible as an end-use report. Visually, it follows the golden ratio, where widths are usually longer than the length. In addition, we can really, as a visual, we can really see patterns across time. So it really allows us to quickly grasp information in a very easy and ready to use format. However, it really becomes difficult in data manipulation. A lot of newcomers to data analytics, data science, they receive data in this format and begin working on it. And a lot of the operations tend to be very complex, very intricate, and namely is because the origination of the data really was in this wide format. One thing to also know, that year is really a data element shows up as the column headers. However, we probably want an indicator for year, right? And so this wide format, it spreads out a specific data emissions across years, and we don't even actually know what the data numbers is by essentially viewing this outright. And so we really need a more conducive format for more intricate analysis and functionality. And so it enters the long format type. This really stores less metadata, right? You have less columns, less attributes and data types to manage in such a structure. And with this format, you can run a lot of more efficient operations, more vectorized operation without loops. If you with that wide format we just saw, in order for me to run certain applications, I'll have to iterate it across all those columns, right? Because years spread out, accordingly. But in a long format, we can really be more robust in our operations. And then merging and appending is easier, and it scales even better. And then you can aggregate with visible groups, types, and so. And then it lends toward other operations such as plotting. You can specify various grouping facets, and add other stylized dimensions to it. And Pandas has many tools to really render a wide format to long. Two methods here is the melt command. You just pass in your data frame. You specify which of the variables will remain intact and which will be pivoted, essentially, from wide to long. And we create a new year column, which was the old column headers, and then identify the value type being emissions. Here's the head and tail of that operation, and then there's the wide to long. Wide to long tends to be better if you have stub names. In this case, we do not. So we're going to pass an empty string. We specify the indicator, the I variable, and then the new J variable, which will be rendered with our reshape. And then just a couple of cleanup operations, resetting the index because these become indices if we want to interact with them as columns, and then rename columns to a nice clean format. And one great aspect too of working with wide formats is that it really is very conducive in working with multiple groupings. The earlier data set was actually an aggregate of all greenhouse gases around those inventory sectors. However, that data port, the US EPA data port, also allows you to split it by the specific greenhouse gas, namely carbon dioxide, methane, nitrous oxide, and fluorinated gases. So with those separate CSVs, we can run a list comprehension through them, set up the indicators, columns, rename accordingly, and then concatenate it all into a nice, clean, single data frame. So this just showing the first five rows, and as you can see here, we specified the greenhouse gas that really that data corresponds to. And so from here we can really then tackle a lot of the typical analytical high level type of questions. What is the overall average or median by greenhouse gas, or by sector, or both? What is the yearly average or median? And what are the time trends by these various groupings? So we can answer this better in long form data. We'll apply the MELT as we showed earlier with a group by for aggregation. This is answering these aggregate setup. And so we go ahead and melt the data, get it a nice format. Notice now all of our groups are in their atomics relation, no entity. There's no related columns. Everything of emissions is in the emissions column now. And then that row is then further specified with the year, sector, gas. This is ideally how data sets really is, should be formatted for a lot of operations. And so we can go ahead and from there easily run aggregations, again, without looping and other more complex challenges that the wide format would have entailed. We pass in our numeric variable and then just run our aggregates: min, median, mean, max, standard deviation, get our overall picture. Then we can add groupings with the group by call. This time this is just by the sector. We see how those aggregates shape out. Greenhouse gases, we can swap out that grouping for a nice specification there, and then by year, and then we and so it delineates those aggregates annually, and then we can even add multiple groupings. Here is sector and greenhouse gases in the group by output. So as you can see here, had this not been in a long format, we would have to do a lot of manipulations to even be able to specify the grouping dimensions, and then and even acknowledge or set up the numeric column. And so the long format is very conducive for that respect. And then we can even go to plotting. The Seaborn interface really runs better on long form data. And so we can do that and specify our X, Y easily, our hue columns, our row or column, should we specify that, and then all sorting accordingly throughout all those groupings. We'll go ahead and add our styles, our setting our X and Y axes and titles and overall framework, and then able to easily furnish a nice representative data, slice and dice as we needed, in a nice clean format. And again, a lot of the heavy lifting is really streamlined, again, just with working with a more suitable and conducive data frame. We're not working with wide data, we're working with long. And then even more sophisticated graphs. Here is the same seaborn now with added dimension, running off of the facet, a grid type structure. This time we can see how these emissions break out by their gas and according by their sectors. Seeing here energy is the dominant form overall in the carbon dioxide aspect. Hopefully overall I was able to really illustrate how long formats, is the more preferred way of running analytical operations. So should you ever, tackle a data set project, the first thing you really want to do is what type of format are we looking at here? Or is it wide? Is it long? And how what can we do to reshape it into the long format for our overall needs? So thank you so much for your time.